start recording. Okay. So for today class, right, we're gonna talk about closures and event loop. Okay. Before closure, right? What is closure now? Okay. Before we understand that, let's try to understand the lexical environment. Let's understand the lexical environment, right? First, okay. So I just copy this code, right, from here to this drawing, right? So see, our goal is to understand lexical environment, right? What is the lexical environment? Basically the place where you can access, right, the variables and the function. Okay, so if you look at this function x, this function x, right, this function you can look at here, x function. Inside this function we have a variable is declared, and it has the 10, right, value 10. So a is inside x function. Okay, it has the scope of x, right, means you can access. When we say scope of x means what? You can access this function inside this x only. You cannot, like, if you want to access here, right, you cannot access, you don't have access to this a. Okay, so this is scope inside x. Now I have y function here, right? This y is also inside x. So this function, right, y can access a. Why? So that is the point now, lexical environment. Okay, let's try to understand. When you call this function x, right, when you call this x, when you call this x, what gonna happen? I mean, first try to go through here, right? You're gonna create, I mean, this, look at whole this step, right? Look at here. You're gonna call this function x. We don't have anything outside, right? We don't have anything. So you have just function x here, correct? Function x, right? That's it. You define the function here, correct? It's the whole function. In the global execution context or global memory, right, you have this function x. Remember that. Okay, that is all you have. You execute, right? You execute function. So your code will run this x execute, right? What happened now? When any function execute, right, it will create new execution context for function, right? For function. So you have the memory here and the code to execute here. Remember, this global execution context, right, enter inside here. Okay, so I can call it here global execution context. Inside the call stack, it is sitting here. Now this function will enter again, right, because this function is executing. Okay, so enter inside the call stack, it will go inside, right? Now in function, what you have a variable here. In the memory you're gonna get a, right, and you have 10 value, 10. Now y function, again same thing, you're gonna define the whole y function here, right? And the y execute, later you executing y here, right? Y, you execute y here. When you execute y, what happened? You're gonna create, like you're gonna have y again enter inside here, y function. So that y will create new memory, right? And the code execution, same thing, y will create new, which will go inside here. So let's call it y function, right? Y function. We have x here executing y. So y gonna have memory and the code. Y, like y don't have anything. Okay, right now y don't have anything, right? It's just like console log. So this is the console, right? Console log a. So now remember, this y is lexically inside x, and x is lexically inside global, right? So children, like child, y is child of x, right? So y means, when I say lexical environment, what happened, right? Y will remember the functions and variable of x. So see the y we're gonna have access to x variable, right? And x gonna have access to global variables and functions. If let's say if I have maybe x, let's say g variable here, right, in the global 20, I can access here, even I can access here, right, to this z. So the reason is, look at this loop, I mean this formation, right? Y is inside x is inside global. So we can call it y is lexically inside x function and x is lexically inside global, right? So when you are lexically inside your parent, you have access to y can have its own variable, right? Y can have its own variable. So when I say lexical environment means local memory, local variable, local function, and parent variable and parent function and its parent, right? So that's how the lexical environment work. Okay. So in call stack, when there are chain like this, right? In call stack, you know, you enter global will enter. If global has function, right, that function will enter. If that function has another function inside, right, running, then that function will enter in the call stack. So this will do the job, it will be out, then this will be out, and then finally this will be out, right? So remember this part, okay? Y is lexically inside yes x. That's why y has access to its local memory and its parent memory, right? And its parent again, x parent also, right? That is global. So that is all about lexical environment. I hope everything is clear now, right? So now, right, if you read through here, a lexical environment is a reference to the environment where a function is declared. Reference. So y is declared in x, right? So the y has reference or y has access to everything in x, and x parent, that is global, right? The y is inside x, so it has access to x lexical environment. When I say x lexical environment means anything in the global, right? Outside of x, that is here. If there is any variable in the global, if there is, let's say there is any variable, maybe z or whatever, right? Then x has access. So we can call y is inside x, so it has access to x lexical environment. Even though y does not have x on a, right, variable, it looks up in the scope chain, okay? Scope chain. Even this is also a scope chain, right? It forms like a chain, okay? So the y has a scope of x. X has a scope of this global, right? Local memory plus global memory. So remember this format, okay? And it should be clear, right? So the next thing is what is closure now, right? So just look at here, right? This function, look at this function, okay? This function, and I'm gonna put this in the code, right? And try to explain. So basically closure is like closure, right? Is a way of binding the lexical environment information, okay? So what I mean by that, in this function, right? Let's say y is console logging a, and then you returning the y. We don't have to execute here, right? We just return it, return the y, and you call the x function, right? And what you gonna get here when you call execute x, so you just get in from the x, you just returning y, right? That means y function will be stored, this y, when you return this y function, that means you are returning this whole thing, that will be stored in z, right? So z has now function here like this much, right? This much function, you know, z has, when you call, because z has now function stored, when you execute z, it will print console log a. So how z remember, right? How z remember this a variable? How? That's the point, right? So the because of closure, okay? when you are inside, lexically inside your parent, right? When you are inside your parent, and even you return back from your parent function, you are returned from the X, and that parent function is execute. Remember, because of the lexical connection, scope chain or lexical connection, right? This Y has access to this A. So that's why even this Y is stored in J, right? And you execute J, it, it will still print this 10 because of this situation, okay? This lexical connection, right? No? So I'm gonna put this code in the our script and try to go in the browser, right? And I'll show you what is lexical environment there, okay? So let's go do that. Uh, we're gonna go back here and index.html script.js, right? And I'll put the code here. Same X, you see the A equal to 10 and Y function, and we just return Y, right? Because I want to show you, like, like even X is called here, right? Execute, and we are returning Y. That means Y function, this Y function is stored in Z, right? That's why Z is a variable which has a function. It's same like, Z equal to function, right? You can write function here, right? Like this, okay? So Y is same thing, this function, returning that Y, right? That means, it will store this function here. Now you can call Z, right? That is what it means, okay? So the point is how Z can remember A and all those things, right? Because of that scope chain or lexical environment connection, right? So let's go and add here. Okay, so now, right, I will go live view, inspect, and source, right? So I'm going to go to the script and try to maybe just pause here, right? Pause here, maybe just pause here, or also just console log, right? Just pause in console log. I think that should be good enough. So let's run this code again, right? And try to understand. I mean, you understand the execution context and all those, right? See the global Z, because we pause in Z, right? Now if I click on the next step here, then Z will receive this X execution, right? Like it will receive the value, okay? So try to look at here in the call stack right now. There is global anonymous, right? See, you can see this anonymous function, right? That means X is inside here, and soon we execute one more time, right? So the Z function, right, got what? Y, correct? Uh, Scope is there, Y, right? So Z now receive Y function. Look at here, function Y, okay? And then let's see, Z has Y, okay? That is just a script, right? So let's click one more time and reach to the console log A, right? Because our goal is to understand, like the scope uh, closure, right? Just to check the closure, okay? How this A is now inside this Z, right? Z function, okay? So click one more time and we reach to the, now we try to print A, right? Console log A. So look at here, just try to pay attention now. We are executing Y function, okay? Y function, right? So Y, now this global execution, we have Y already entered inside the call stack, and now it forms a closure, right? So Z function, Z variable has Y function here. Inside call stack, Y is now executing also, right? Y is also inside the call stack. You can see that, okay? And because I did not pause X, right? I did not pause X here. I mean, I pause here, but X is just returning the Y, right? So that is all we have. So that is fine. We saw Y return value stored in Z, right? We saw that one. Okay. So global, uh, that is anonymous in call stack, right? And then Y you can see entered in the call stack because Y must print console log A, right? That's why it's in the call stack. But A variable, where A coming from now, right? Look at this closure. So the function bind together, right, with its parent variables and function, okay? And that's formation is called closure. So if I expand this now, right, look at y, y function has access to its parent x variable, right? So see, these all are in the memory. That's why, we still, I mean, y still remember, or z, right? Z still remember y function, okay? Even you execute z, right? That is equivalent of running y function, and y remember its lexical environment, that is the variable and function, right? We can call it like variable and function of the parent, that is x function, and that forms the closure. And because of that closure, right, it access, I mean, we look at the lexical environment, right? And because of that lexical environment, closure is formed. And because there is a closure, right, that's the reason, we have access to that variable, okay? So, when somebody asks you what is close, define the closure, right? So you can just simply says, the function, right? Remember its parent or its lexical environment, okay? The function remember its lexical environment. So y remember its lexical environment, that is parent x variables, right? And if there might be anything global also, right, it will, even x lexical environment means x uh, parent, right, that is global, it will remember, okay? It will remember. So that is the scope. I hope that is clear. There is a video, right, on the bottom. You can watch later, okay? There is two video you can watch. So that is good enough for the scope chain and lexical environment, right? So it's always the same situation happen, any function you execute, right, same thing gonna happen, okay? The global will enter in the call stack, and the function will go there. If there is any other functions, it will just go on the top, right? And it will start from inside will finish the work, then next and next it will go down. I mean, it will go up to the down, right? From, like, inner one would do first, like this y will execute first, right? And then if there is something in the x, that will be done. So I hope that is clear. So let's look at the event. Next is the event loop, right? We're going to go to the event loop. Now let's try to look at the event loop. So what is event loop now, right? That is the point, event loop. See, I'm going to explain in the short, right? Let's see. Let's draw this. If I go to the console here, right? And in the console, just type window, okay, window, right? Look at this object, okay? This is the global object, right? And this object is part of what? Part of this browser, okay? This window is part of browser, and this window, has so many good things, right? Like, the different APIs which JavaScript use to do different things, right? Like, for example, we have DOM API, remember that? So let's look at a couple of API. I'll just write here, right? Like even console, right? Console is the part of window API, okay? Console log, right? So API. So I'm going to talk about, this is a window, window objects. This is a window object which I just show you right here. Just imagine that. So we have console. What else we have, right? Document dot get element by, so this will help us to access our HTML, right? access HTML, or basically handle the document object model, right? Different functions used to get access to your element in the JavaScript, modify, do whatever you want to do, right? So that is document. That is also part of the window. Fetch, we look at fetch, right? Fetch, you know, so fetch will be used for what? Like asynchronous, not async, let's call it fetching data, right? Or maybe sending data, whatever. HTTP, you know, call, right? So if you have to access data from the APIs and all those things, you use fetch. What else we have? Set timeout, right? Set timeout. That is also part of set timeout, right? Part of the window API. So these are the powerhouse, right, of the browser window API, which JavaScript use to do different things, right? So like there is something called event loop. Okay, let's call this event loop, right? Let's type here event loop. Okay, loop. So until now, we have studied what JavaScript is this single threaded programming language. Single threaded means it has only one call stack, right? It has only one call stack, correct? uh, and each line of code, right, run one by one. Let's say if there is console log, that will go inside here first and execute the code. If there is function, right, then that function will enter, but before that your global execution context will enter here, right? Global execution context. And then after that, any functions or any console log or any other code, if there is, right, it will go inside, but line by line. Okay, line by line, one code will finish. If there is for loop, right, that for loop will finish first and then move to the next line of code. Okay, so that's what we call it single threaded programming language, because of one call stack. Now when you have like you have different APIs of the browser, or asynchronous, right? Async code, correct? Async code we have studied, right? And in the async code, what we have done, callback function, let's call it callback function. We used to have, right, callback function. So when something takes time, asynchronous code or asynchronous programming, right, which takes some time. So let's say if, right, something is taking a lot of time and that function enter here, and it will, because of one call stack, what gonna happen, right? It will block the thread, means the next line of code will be blocked, right? So that is, now if that happen, then our JavaScript code will never work, like our website will be like freeze, right? It's not gonna do, like it has to display so many things, right? And it just stuck there because our call stack is busy with one of the code, right? Asynchronous code. Okay, so to avoid that difficulties, right, we have concept of event loop. Okay, so what happened when you have async code, right? It will log that, because every function has callback function, it will just log here in the browser, like they will enter inside here, right? But when they see async code, what happened, it will not wait, it will quickly send that code to the that callback function and just log inside the browser, just waiting there, right? Waiting until it finished the work, right? Until it like completed or fulfilled, right? Let's say in case of promise, what happened, it will be once it complete, then that callback function, right, will be sent to where there are now concept of uh, event loop, right? Event loop, or what is the name we call it, right? Let's see. So let's quickly read through, right? JavaScript is a single threaded language, meaning it execute one task at a time in synchronous way, right? Synchronous manner. However, JavaScript can handle asynchronous operation using mechanism like callbacks, promise, async await, and event loop, right? So how event loop work? That is what we're trying to understand, right? So the event loop is responsible for handling async operation by managing the call stack, event queue, and micro task queue, right? So there is two things, event queue and micro task queue. Okay. So what I said, right? My callback, like we can take one example, right? We can take one example. Let's take here in this time, right? Let's say console log start. It will print quickly, then set timeout, and here is a callback function inside, right? And this callback function, even though the timer, you can add timer 5 second, 10 second, right? Still, because this is a callback function with a set timeout, API of the browser, right? Async, this will be now async call, okay? So it will print start, it will print end, then only this inside set timeout will print, right? Because what happened, this callback function will enter inside this window, right? And wait here. Let's say if there is timer, right? Once the timer is expired, because browser has something called timer now, right? Set timeout, and it has a timer. So when timer start, this callback function will enter here in the event queue. So we can call this event queue, right? There is something called event queue. QUEUE, right? Something like that, okay? Event queue. So this will enter inside here. Let's call this callback, right? Callback. This function enter inside here. So we have start. I mean, you can print start. That will be done quickly, right? When you hit here, this callback will be sent to the window and wait here, right? Waiting here, okay? And it will go to the end part. It will just print end, right? Done. Now this time expired. It will enter in the event callback queue, right? And this event loop is what? This event loop is now continuously monitor what? It will keep moving, right? Means it will keep monitor our callback, sorry, event queue. It will monitor this one, okay? Is there any function waiting in the line, right? If there is something, also it will monitor this call stack, right? Oh, okay, so my call stack is empty and I have a function ready to go. It will grab this and push inside the call stack, right? And then after that callback function execute, correct? So if I bring this function quickly, right, and just go to the our script, let me comment this out, and I will just put here, right? Let's add some timer so that you can see maybe after 5 seconds, something like that, right? Okay. Yeah, so it should print start, end, right? And this callback function will be go to the window, wait there. I mean, this set time out will enter in the call stack, but soon it sees this asynchronous, right? It will not print. It will send this callback to the window and wait there, okay? And once the timer expire, what I said, it will push to the callback queue, and event loop, which monitor, right? Event loop will check if there is something waiting, yes, and a call stack is empty, yes. It will grab this and push inside here to execute. That is the process, right? So like if something is not promised, right, like something like fetch or our async await, if there is just a callback like this, or even our event loop, remember we have the code we studied in our to do app, like you get document dot get element by id, right? By id, something like that. You have the btn button, right? And then inside you say add event listener, listne, something like that, right? And you had a click event, correct? Click event. And then there was a callback function, correct? Right? That function like add to do or something, you can write callback function event here, right? So now what? When you click the button, remember this callback function, right? This callback, let's call this callback function for now, callback function. We can name it, right? Maybe callback function here. So this function basically is waiting in here, okay? It's just waiting here in the window. And when somebody click the button, right? Then that function will, how the, like you have button and you have the click event. When somebody click the button, maybe in the future sometimes, right? Then that callback function will be pushed in the event queue here, and this event loop will grab that function. If this is empty, and then it will just push in our call stack, and the whatever code inside this callback, right, will execute. So that's what happened. Okay, so anything related to callback will go in the event queue. And we have micro task queue, right? So micro task queue is for promise, like set timeout. Sorry, not set timeout. Async await. Then method, right? Then when you have promise, that will go in the micro task queue. Okay, micro task queue, right? So there might be in the interview, they might ask you question, right? They will give you like like console log, normal console log. Then they're gonna give you the maybe one of the set time out, right? And then micro task with the promise. So who has the higher priority now, right? Basically, console log will be the first one, right? Console log will print first one. This console log will go first. Then if there is micro task queue with promise, right? So the promises has higher priority. Okay, this micro task queue has higher priority. Remember that micro task queue, right? QUEUE. This has higher priority. Okay, PRIORI priority, right? So if there is something from the fetch, or let's call it maybe like you have a function right here. Let's write one simple function. Can I write like async function, right? Let's call it get data, maybe like that. And then you have a const data equal to, right, await it's, and inside here you have http link to get data, right? And then you have maybe const again result or whatever, right? Result equal to await data dot json. Fine, so you have something like that, and then you return maybe result, or just use console log result here. Let's console log result, correct? So in this case what happened? Async function. So this will enter in the get. Let's say you execute get data, right? You execute in the global here. This function will enter in the call stack. It is async now, right? That's why the callback function basically, like this fetch function, or let's call it callback function, will enter, like will be added in the window here, right? The promise will be added here, right? Now when it is success, when it is fulfilled or declined, whatever, right? When the status is complete, because of the asynchronous function, right, it will be entered in the micro task queue here. So now, right, you have, let's say you have one callback and you have micro task queue. What happened? This function will be, this loop, event loop will take this function first. Okay, so this has higher priority, and then only callback from the maybe like event listener, click event, or maybe set timeout, or any other callback function, right? As long as it's not promise, you know that will be second, right? The promise will be handled first, and it will handle second, but the process is same, right? It's just two different queue, event queue and micro task queue, right? And then event loop continuously monitor these two field, right? So normal functions, asynchronous functions, for loops, any other stuff, or console log, that will be quickly handle, it will be keep running every time when there is callback function, or promise, right? That will be pushed to the window. Just wait there. When they have done their work or time expired, they will be sent to the event queue. And in case of promise in the micro task queue, an event loop will monitor that, and based on the priority, it will be pushed to the call stack and they will execute. If there are many micro tasks, let's say promise functions, right? They will be in the queue here. They will get in the line, okay? And the first come, they will be sent back to the call stack. Just remember that. So that's how it works, right? What I will ask, just read through quickly here, right? Just it's easy to understand, and there is a visual, these two video, maybe 10-15 minutes, right? Just watch it 1-2 times. That will be much clear understanding, right? It has much visually, you can see everything how it. I mean, same what I said, right? The revision. It will be better do the revision, right? Okay, guys. So that is for our today class. Tomorrow we're gonna talk about the prototype object-oriented programming, right? And we'll see if there is something more we're gonna talk about. But let's finish the prototype tomorrow, and then yeah, and then we're gonna look at the maybe Node.js and other stuff, right? We're gonna plan how we're gonna proceed with the Node.js. Basically, talk about the backend and all those things, right? We're gonna slowly move to the Node.js, Express, MongoDB, and middleware backend things we're gonna talk about, right? Before we start our React, okay? So in between this time, mostly the theoretical part, right? A lot of theory, like like what we are doing, right? Understanding the concept, uh, those things, right? Before we basically start to React, and then the practical, like a lot of things will be practical after that, right? Projects, exercise, and so many things. But even in the backend, there will be exercise, okay? In the middlewares, we're gonna create a backend, and then we can try to use our Postman to test our uh, APIs, right? So those are the practical things guys will be practicing, okay, a lot. I mean, there will be certain things which you have to do many revision, right? Do it many times. Simple example, but do it. Basically, you memorize it, right? And always try to follow that. Okay, guys. So I'll stop here.